Hello everyone, good afternoon. Thank you very much for joining this lightning talk this afternoon. I want to talk to you about mobile application security today and also the threat landscape. What particular attack vectors do we find Android applications under? Here at Verimatrix, we have our own cybersecurity labs looking at various attack vectors that we see in the real world. So no longer just talking about this as an academic problem. My name is Keir Storrie and I'm our expert at Verimatrix on all forms of mobile attack vectors. So I've been working in the industry for a large number of years. Too many years, some people might say. So I've built up a great wealth of experience on the way that reverse engineers attack applications, about the way that mobile malware will attach to running application processes to steal data and to make modifications at runtime. They do say that you should start these kind of presentations with a joke, so mine's is very on target. What is a Chief Information Security Officer's two biggest fears? Everyone who works at the company and everyone who does not work at the company. And that is quite a serious way of looking at the way we as developers, product owners, security engineers need to look at how our applications are delivered and used in the real world. So to understand that, we need to look at the threat landscape. And the first thing that I want to talk to you about is mobile malware. So we see as a security organisation many different types of malware delivered to Android devices. These can be delivered via social engineering attacks. They can be delivered via innocuous dropper applications like cheap and free games that you get from the App Store. But the real point of these things is that they will call out to command and control servers and deliver malware to the device. The malware will then attach to a trusted application. Your banking application, mobile payments, e-health, insurance, something where there's a real requirement to ensure trust in the data privacy and also in the transactions that are being processed by these applications. There is a form of malware out there to steal and pervert that data. One very good example of this is Gold Digger. So Gold Digger started a few years ago where an overlay was delivered to the application, to the device, and that would be used to steal credentials. Could be then used in a social engineering attack in order to empty money from bank accounts. But like any good software, it evolved. We then got Gold Digger Plus and Golden Pickaxe, or Gold Pickaxe, which is now really the standard for mobile malware delivered to both iOS and Android devices in order to empty money from bank accounts. So we're seeing real world problems here that are no longer being discussed academically, and we need to have robust solutions in order to ensure that our applications are protected in hostile environments. And hostile environment for me is a consumer mobile device where we have up to or over 100 applications on our devices, more than 21 billion connected devices worldwide, more than 7 million applications on the app stores today, and that's before the number of app stores actually expand. We have a huge explosion in terms of the potential for malware to be delivered to mobile devices and to be used against us. This is not just a problem that we're seeing in particular geolocations around the world. We certainly saw a large surge in these attacks in APAC over the last few months, but we're also seeing these attacks in Europe, North America, and LATAM as well. So the more months that pass, the more this becomes a serious problem that we need to be able to address as developers, as product owners, as service providers. Second thing in the landscape that probably more known to developers is the improper usage of credentials and API attacks. Our applications are nothing without APIs. These APIs connect to our service backends and complete transactions. So there's a trusted relationship regardless of the market vertical that we find our application in. And as you all know, if you look inside Android bytecode, even if you look inside binary shared objects, you are going to find lots of examples of credentials, usernames, passwords, API keys. And these things can all be reaped from an application and again used against us. They can be scaled up in order to execute tens of thousands or hundreds of thousands of times against a service's backend. So get in and get out quickly before traditional cybersecurity systems will be able to detect and respond to that. You may have web application firewalls, you may have network traffic analysis, you may have intrusion detection systems, but if these things are all happening inside a few tens of seconds, very difficult to be able to contain the size of that particular problem. When we look at market research out there, security labs, when they look at applications on the Google Play Store, they will say that there is a huge number of applications containing API keys or some other secret. It may be to a third-party library, it may be to your own service backend, but the fact of the matter is that these things are not well protected inside an application package or particularly inside the Android bytecode. The third one, and probably the more damaging one, is the repackaging attack. So we see this all the time, where someone will download an application from the Google Play Store, decompile it with one of many freely available tools, inject malware into that application and repackage it, deliver it to a sideloading store, or to deliver a clone of the application to the Play Store. Google do a great job of filtering out these applications, but it only takes a few people to download it before we have a serious problem that we need to contain as a brand. Other types of repackaging attack that we see is just static modification to our application. It may be that we want to remove a monetization surface. It may be that we want to remove an authentication gateway. It may be that we just don't like the look and feel of the application. With access to the Android bytecode, we can easily make modifications and repackage that application. It may be that we just want to clone the application so that we can have our own monetization of your hard work and development that you've put into an application. So some really good examples of that over the last few years. WhatsApp Gold. I don't know if anyone downloaded WhatsApp Gold. I have to hold my hand up and say I did, but I did it as a security researcher. So obviously the social engineering attack was in place. I want to be a Gold user, I'm not a normal user, and before I know it, all of my messages are being recorded to a third-party server, and I had no idea that this was happening. The application looked like WhatsApp, the application reacted like WhatsApp, but there was this malware running inside the application to record those messages. So the question is, it's not secure. Android is not secure. I'm sorry to anyone from Android hearing me say that, but the operating system itself allows us to do very bad things. So what should I do? Well, any attack will start with a reverse engineering attack. We intercept the application from the Play Store, either by downloading to a device or going to an APK archive, and we have something that we can decompile, investigate, and work out how to attack. And there are lots of free tools out there to allow us to do this. There's absolutely no problem in taking an APK or even the individual split APKs from an AAB and being able to properly investigate the bytecode here. And these tools are only getting better on a month-by-month basis with all of the new AI techniques that are out there. I saw a great demonstration recently with an application where the developer told me, I have great security. I've used R8, I've applied symbol obfuscation, I have minified my application. I said, I don't care about that. I didn't care about it 10 years ago, I don't care about it now. I will dynamically instrument your app and then I will know exactly how it works. But with these new AI tools, they will call out to GitHub, scour for bytecode signatures and be able to tell you exactly which packages, classes and methods you have inside your application. So symbol obfuscation as a security technique simply doesn't work. But there are techniques that we can apply and there are vulnerabilities that we can look for as developers. The OWASP Mobile Top 10 is a great example of the obvious vulnerabilities that we want to secure any application against, regardless of the market that we're in. It may be a gaming application where we want to ensure fair play. It may be a healthcare application where we want to ensure data privacy. It may be a mobile banking application where we want to make secure payments. The fact of the matter is, as brand owners, we do not want to be the host of malware. We're really talking about risk mitigation, and risk mitigation comes in multiple forms. Primary form of loss for a brand, for a product owner, is that customers will lose trust in you and they will move to another organisation. Another form of loss is the fact that you will just not be able to generate revenue or get return on investment for the development effort that you've put in. So risk mitigation is very important. So understanding OWASP helps us to realise that, well, I can apply code obfuscation, so very different to the symbol obfuscation that we get with ProGuard or R8. Code obfuscation will actually scramble the logic of our apps in order to protect our APIs, to protect our intellectual property from reverse engineering. And if we can close the door on reverse engineering very early, then there's little for an attacker to understand about our application in order to make static or dynamic modifications. Now, code obfuscation comes in many forms. We can take an if statement and we can flatten that, so making more code to read. We can unroll a for loop. We can inject junk code or dummy code. We can obfuscate strings. We can substitute literals. We can inject goto statements, all with the effect of making that code very difficult for a human brain to understand and therefore to modify. Let me give you an example. Here is an application where all I have done is pass the APK to the tool, and it has gone ahead and completely decompiled the Android bytecode. Not only do I have access to all of the packages, classes, and methods of this application, but I have all of the assets, all of the resources as well. And like I said, even if I was using symbol obfuscation, it's the bytecode that I'm very interested in. I identify a mechanism that I want to remove, I identify a mechanism that I want to modify, switch to Smiley, change the Smiley, recompile, and I have my modified application. It is that simple. If we apply a really excellent example of code obfuscation, we now no longer have any API in this APK. We've removed all of the packages, package names, class names, and methods. So effectively, we've shut the door on this reverse engineering effort. We're going to have to go to a much more sophisticated level, which would be to compile the machine code in our shared objects. So I'm sure everyone here knows that understanding very high-level languages like Java or Kotlin is very different from understanding low-level machine code representation of an application. Other things that we can do in order to ensure the integrity of our apps is to add anti-tampering mechanisms. Well, anti-tampering mechanisms come in multiple forms. We want to make sure that no one can modify our bytecode. We want to make sure that no one can modify our shared objects. We want to make sure that no one can modify our assets. We want to make sure no one can modify our resources. But beyond that, we want to make sure that our application cannot be repackaged with malware, cannot be cloned, cannot be re-signed. So with these combination of anti-tampering techniques and code obfuscation, we can ensure the integrity of our application when it's delivered from the Google Play Store to a device, and we can then look to how we would actually execute the application on a device. Well, for that, we want to have environmental checks. Are we running on a rooted device? Rooted devices are not always evil. They certainly allow applications or services with elevated permissions to run. But you might be a game developer and you might find that 50% of your clients have their own modified version of the kernel to gain optimizations. So you would like to have a flexible response to the detection of rooting here. We also might want to say, I don't want my application to run on an emulator. It needs to be a real physical device. I do not want to run on a virtual machine. And this is very important because we don't want attacks to be scaled up against us. Easy to believe that an attacker might have 5, 10, 20 devices, but highly unlikely that they're going to have access to 10,000 or 100,000 devices that will allow them to scale an attack against your service. We definitely don't want to allow someone to attach a debugger to a running process. That's where we're going to lose very sensitive runtime information. We certainly don't want someone to attach a hooking framework. So for anyone that doesn't know, a hooking framework is something like Frida, where we can interrogate the runtime of the application. We can identify the activities, the intents, the methods that are running. We can see the parameters that are being passed in to these methods, and we can see and modify the return values from these things. So imagine someone has constructed a very devious piece of malware, delivered it to your device via a social engineering attack, and this malware all it's doing is looking for authentication classes, encryption classes, transaction classes to be executed, and then to inject its own mechanisms. So we're seeing real world versions of these attacks, so this is not a scare story, this is not an educational discussion, this is something that we need to be aware of and to make sure that we're protecting against. Obviously now we're seeing government regulation around the world where there's a real requirement in order to have to consider these things. In Europe for a number of years we've had GDPR, now we have DORA to contend with. So the Digital Operational Resilience Act has gone a lot further than GDPR has done before in order to ensure data privacy, data protection, binary protection for any service applications that are out there in the real world. Everyone might not know, but 70% of the world's economic growth is going to come through interactions with mobile applications over the next 10 years. So, in order to ensure revenue, we need to make sure that we're protecting these applications. So what we need as developers, as product owners, are risk mitigation controls. And these are preventive, detective, and corrective. We need to protect our apps, we need to detect whenever we're being attacked, and we need to have a flexible countermeasure to say, I want to stop this application from weaponizing my APIs against me, and from potentially generating fraudulent transactions. Well, really, in order to do that, we need continuous real-time threat detection. Continuous real-time threat detection will give us a fine-grained list of all of the security events that happen against our application. Has someone tried to run a modified version of my app? Has someone tried to run on an emulator? Has someone tried to connect to me via a VPN or a data proxy, or tried to execute a man in the middle? All of these behavioural analytics give us a powerful capability to identify high-risk actors, high-risk devices, and then to automate the response to those to say, 10,000, 100,000 bad actor devices, I cannot allow them to weaponize my services using the mobile and its APIs. The corrective responses can take many forms. It may be a remote kill switch. Do not allow my application to run on this device until I tell you otherwise. As much as you can suspend an app, you want to be able to resume an app. It may be that you want to delete the cached data on an application in order to force a resync or a re-authentication. It may be that you want to force an upgrade of the application to the latest version from the Google Play Store. This is what I mean by flexibility. Given the behavioural analytics, you need to work out what's best for your organisation and your services. Product pitch time. Here at Verimatrix, we have built such a system, and we've built a system that is incredibly easy for app developers to use. We have either a SaaS-based system where you can automate the upload of the application to Verimatrix. We will protect that, deliver the protected application back to you, ready to go to the Play Store. Can be easily integrated with any CI/CD system that you're using today, can be easily integrated with Gradle as well. So there's no complicated configuration files to deal with. We simply say, assemble our application, protect our application. It can be that straightforward. This is not an SDK solution where you need to make modifications to your application on a continuous and ongoing basis in order to ensure that the protections are applied. That introduces the human being into the loop where there's a potential for an important part of the code to be missed here. So the intelligence in the Verimatrix solutions will work out where best to inject the defences without impacting the user experience. We have customers who have very tight timing requirements in their application, whether or not it's media codecs, whether or not it's games, whether or not it's NFC payment transactions. So with our technology, we can meet very tight timing requirements. We also have this server-side processing capability where we record 50 or so indicators of attack from a device. None of this is person identifying information, and it's not application level data. So we are compliant with GDPR, with DORA, with the California Consumer Protection Act, with HIPAA, with any regulation really that's coming down on us around the world. What we do with these 50 indicators of attack is process them with AI and ML. If we are protecting hundreds of millions of devices, we need to have an automatic mechanism to learn how the indicators of attack will result in a particular type or classification of attack against us. So what that allows us to do is to do things that we cannot do client-side. So there are new attacks coming out with accessibility malware, so weaponizing the accessibility services on Android to deliver overlays to devices to steal usernames and passwords. With all these advanced threats, we need advanced technologies in order to protect against them. At Verimatrix with XDD, we have built such a system. So I'm sorry I took a bit longer than I expected to with my talking there, but if anyone does have any questions, I would be very happy to answer them.